what are we up to today? Well, I've been covering myself in iodine from side effects from MS treatment. But in the meantime, I have been dealing with flasher cans, in particular EG23 24 volt Tridon brand flasher cans. This one has come out of my 6-wheel drive ambulance. Now, where this flasher can's function was to use 24 volts to flash the 12 volt red lights, a third globe in the red lights in the back of the ambulance. I'll shove a picture over in the corner here, and that will show you the state of the lights when I found them. Now, that was corroded and shorting out and causing all sorts of problems. And this relay was having a bit of a buzz in the back. Also, additionally to that, the revolving lights come on as well. Now, the revolving lights are 24 volt, but they are triggered from a 12 volt line from the front of the cabin, which that relay then powers this relay with 24 volts, which then switches the 12 volts for the lights at the back, which are through a trailer plug on the rear door. This is Lucas wiring for you guys. So, when I replace this, those lights flash instead of buzz. Now, my apprentice has some friends over at the moment too, so you might have to deal with some of that background noise. Anyway, we're going to cut this open and dissect it and see what went wrong. Because in all my years, I've never opened an electronic flasher can. So let's get these cutters in and see what we can do. So I'm making some little strategic cuts in this rim around here in the hope that I can open it up enough to get a spudger underneath. Although this stuff is actually quite brittle anyway. But yes, I haven't bothered to look it up. But as I was explaining just before, I don't actually know how electronic flasher cans work. I know how traditional ones work, but I've never bothered to open one of these and look or even research the topic. So today's the day, guys. And I'll see if some of my assumptions are correct about the difference between 24 volt ones. So we're almost there. I'll open this guy up. Anyway, we'll be back in a moment. One thing I am noticing as I'm opening in this, there is an unwholesome amount of dirt coming out. I think I've got another picture I'll put up here which shows the switch box that this was in. And you may understand why. Now, alright, we have this open. Let's have a close-up look here and see what's going on. So we have a pretty traditional magnetic relay contact here. So this guy should go on and off like so. Now the electronic relays are supposedly not load sensitive. I am noticing pretty immediately that this little washer here is free floating, but I'm not sure if that's meant to be the case. We have a capacitor and a resistor. So I'm going to guess that this is, actually what's this? This is a black brown. That's like 100 ohm gold, 100 ohm 10%? 5% off memory. So it's 100 ohm 5% resistor. So that's kind of a load resistor. Or it could be feed, I'll have to map this out anyway. That could be limiting the current to charge this capacitor. And once the capacitor is at saturation, the relay contacts will close, which of course would open the contact somewhere here to that capacitor, thus discharging it. I guess that's how it would work, and that would just cycle in and out. So yeah, what I might do, I might hook this up to 24 volts on my desk and see if it still clicks. I'm going to switch over to my power supply side of things. We're going to wind ourselves up to somewhere about 24 volts. Probably close enough. Alright, we'll land back on our bench here. Grab ourselves a couple of clip leads. And I'm not sure which way this is meant to go, so that looks like power. That'll be ground, and that's probably L for load. I'm going to guess. We'll find out if we're wrong here for a minute. Although we do know that this doesn't work, so maybe that's some of it. But yeah, oh, there's a little discrete component in there too. hiding away that looks like it has lost its guts all over that capacitor. That might be our problem. Let's switch this off and let's open this up. I don't know how much you're liking these autopsy video guys, but yeah. Alright, so that's not working at all. Let's chop it up. Why not? So let's take Mr. Resistor off first, and you can come out and we'll find out where the failure point is or was. That one is off the relay coil. The relay side of this might actually work alright, so let's chop our capacitor off in here nicely. Let's see if we can get that out. Yep, I'd say that would be the point of failure. So that guy is across the coil contacts as well. So, oh, yep, and he's just broken in half. So I'm not sure what that was. I think maybe a little polyester capacitor. It could be flyback capacitor. I'm curious if I chop these legs off, if I can trigger the relay coil. Let's have a look here. Let's see if we can do this. Oh, no. Nothing on the relay coil. Alright, maybe I'm not connecting to the coil contacts properly. Let's assume that's one of them, and I know that's definitely one of them. Nope, I'd say our coil's blown. But this would be a good source of very fine wire. So yeah, alright, so that capacitor blew and the coil went, so I'd say, yeah, probably dead short is what's killed this, and it's overloaded that coil. So, yeah, lots of nice little bits and pieces and tiny springs and stuff. If I was doing a little project, I would probably pull this apart and recycle all the pieces. Or pull this apart, not two-part. And here's our little contact here that's touching on things too. But yeah, alright, so yes, we know that this little capacitor here was what blew up, and we're reasonably sure that a short circuit caused it. So, yeah. And there's actually a little flat spot in the coil right here where that component's been sitting. So maybe that blew and actually shorted to one of the coils as well. I don't know. Anyway, it's getting noisy in this household, so I'm going to probably go and tend to that. But I'm going to call this quits, and yeah, let me know in the comments what you think of these little autopsy videos. I kind of enjoy doing this stuff, so if you guys do too, I'll do a bit more of it. Anyway, see you in the next one.